In this lesson, we will learn how to determine the maximum and minimum value, so the optimum values of a quadratic function, and find the inverse of a quadratic function. Now, when looking at determining the maximum or minimum values of quadratic functions, there are several ways to do this. And we often call the maximum minimum values the optimum value of quadratic function. So first things to note is the maximum or minimum value of a quadratic function is the y value of that vertex. Now that vertex is always that turning point. So if we have a maximum value, that means our parabola is opening downward. We get to a maximum and then come back down. If, however, we have a minimum, that means our parabola is opening upward. And we know what that a value is positive, and that it gets down to the vertex and then it changes direction. So that vertex is a very, very critical point in our problem. The vertex can be determined from the standard form f at x is equal to ax squared plus bx plus c using three different methods. So we know that we have the standard form. To go from standard form to vertex form, we would be completing the square. Then from vertex form to factored form, we would expand from vertex form to standard form and then fully factor our trinomial. Now, let's start with method one. We're going to rewrite the standard form of our quadratic function into vertex form by completing the square. So by doing that, we're taking it from standard form to vertex form, and the vertex form does allow us to identify what that vertex is. Now, again, the maximum or minimum value is that y value of your vertex. So let's determine the optimum value of the function f at x is equal to 3x squared minus 30x plus 27. We want to state whether it is a maximum or minimum. Now, just looking at the quadratic function equation in standard form, we can already decide whether it's a max or a min based on that a value. A value is that coefficient of x squared, and we see that it's positive 3. So we know this is opening upward. That means it's going to come down to a minimum and then change direction. So we know it's going to be a minimum. So we want to remember the steps for completing the square. So let's start with our original function, f at x. We have f at x is equal to 3x squared minus 30x plus 27. Okay, so step one is you want to put square brackets around your x terms, like so. Now the job is, again, to go from standard form to vertex form by completing the square. The first thing we always do is put square brackets around our x terms. Then we factor out only the coefficient of x squared from both of those terms in those square brackets. So in this case, we see that there is that 3. So if we factor out that 3, we are left with x squared minus 10x. Okay. Okay, sometimes we're tempted to factor a common factor from all terms, but not when you're completing the square. So with that in mind, we need to create a perfect square trinomial. So we're going to take the coefficient in front of x. Okay, we're going to divide that by 2. And it doesn't matter what the coefficient is. The steps is always to divide by 2 and then square it. So 10 divided by 2 we know is 5. 5 squared is 25. So then we say f at x is equal to 3, keeping our square brackets. And then what we do is we're going to add that value of 25 and we're going to subtract it. By doing that, we are not changing our question. All we are doing is creating a perfect square trinomial, because if you add something, take it away, you're not changing that question. So we want to keep that in mind. What we have done, though, is now we have created a perfect square trinomial. And a perfect square trinomial can be factored into a binomial square. Okay, so what are the terms in my binomial? Again, it would be the square root of x squared, which is x. the square root of 25, which is 5, and we keep the sign of our middle term, right? Because x squared, this is 5 squared in a perfect square trinomial. The middle term is 2 times those two terms. And of course, we created that by taking that coefficient in front of x, dividing it by 2, by squaring it. We are actually creating that perfect square trinomial so that we can factor it into a binomial square. So then we have f at x is equal to x minus 5 all squared minus 25. And we want to get rid of those square brackets. Keep in mind that 3 goes right in front, because remember, our goal is to have a vertex form of a quadratic function. So therefore, f at x is equal to 3 bracket x minus 5 all squared. 3 times negative 25, which is negative 75. And then we add 27. Again, these are like terms, so we can simplify that. So we have f at x. F at x is equal to 3x minus 5 all squared minus 48. So now we've just taken it from standard form to vertex form. And from there, we can identify what the vertex is. So we know a is equal to positive 3, so it's opening upward. We know what the vertex is, h and k, which is 5 and negative 48. And again, the minimum is that y value of the vertex. So therefore, we can say, since it's opening upward, we know we have the optimum value volume is a minimum of negative 48. Okay, so we know that the optimum, and when we're stating our optimum value, whether max or min, the a value tells me whether it's going to be a max or a min. A is positive, we know it's opening upward, so then we're going to have a lowest point, and that would be a minimum, and our minimum is negative 48. Okay, that was method 1. Method 2, we can rewrite the standard form into factored form if possible. By doing that, we can determine the axis of symmetry by finding between those zeros is where we're going to find that axis of symmetry, and we know that the vertex is on the axis of symmetry. So we'd add the zeros, divide by 2, that gives us that h value of our vertex, then we sub it back into our original function to figure out the corresponding y value of the vertex would be. So let's do that in example 2. We have determined the optimum value for the function f at x is equal to 3x squared minus 30x plus 27. So keep things at par. We're using the same function, but we're just using the different methods to determine that optimum value. And then we're going to see whether it's a maximum or minimum. So given f at x is equal to, we're starting with the same function, just so you can see the same quadratic function in standard form. We can determine the optimum value using the same equation 3 different ways, and we're going to get the same optimum value, that minimum at negative 48. Now, in this case, we are going to factor out, first start with a common factor, and I see that we can factor out that 3 from each of our terms. Okay, so in this case, my sum is equal to negative 10. My product is equal to positive 9. So if we have a positive product and a negative sum, we know both terms have to be negative. So negative 9 times negative 1 is 9. Negative 9 plus negative 1 is negative 10. So this becomes f at x is equal to 3. Simple trinomial. We set up our 2 brackets. X minus 9, x minus 1. Again, the order does not matter. Now we want to determine the zeros. So we let x minus 9 equals 0. So in this case, x equals 9. Now you may be able to identify right away what those numbers are, but I'm just going to work it out so that we have that as a reference. Okay, so now that we have what those zeros are, to figure out the axis of symmetry, remember it's always halfway between those zeros. We're going to add them together and divide by 2. So that would be the axis of symmetry, but we also know that that also represents the x value of a vertex. So that's going to be 9 plus 1, divide that by 2. We know 9 plus 1 is 10. 10 divided by 2 is 5. So therefore, we know that the vertex, which is on the axis of symmetry, happens when x is equal to 5. So to find the corresponding y value, we're going to say f at 5. I'm going to put it into my factored form. We're going to say 3, 5 minus 9, 5 minus 1, f at 5 is equal to 5 minus 9, which is negative 4, 5 minus 1, which is 4, f at 5 is equal to negative 3 times negative 4 is negative 12. Negative 12 times 4, which is negative 48. So again, the vertex here is 5 and negative 48. So therefore, we can say the minimum is negative 48 as well. A, again, the coefficient in front of x squared is positive. We know it's opening upward. We're always going to have a minimum. Now, the third method is we can take it right from standard form, where f at x is equal to ax squared plus bx plus c. We can use the vertex formula. So this is a shortcut that we don't often use, but I will introduce it to you to calculate the coordinates of the vertex h and k. So if you know, again, the standard form, a value is the coefficient in front of x squared, the b value is the coefficient in front of x, and that c value is that constant. It doesn't have any variables attached to it. Once we identify those, if you wanted to figure out the vertex very quickly, it's always the x value of the vertex is always negative b divided by 2a, and the y value of the vertex is always 4 times ac minus b squared all over 4a. Now, using that method, let's figure out what the coefficients of the vertex is. And again, based on our a value, whether it's opening upward or downward, and it is positive, we know we're going to have a minimum. Okay, so let's figure out what that minimum is. And the minimum value is always, or maximum value is always, the y value of the vertex. So in this case, we have a is going to equal to 3, which is the coefficient in front of x squared. B is equal to negative 30, and c is equal to 27. So if we wanted to know the vertex, we're going to take negative b, so negative 30. And then we're going to divide it by 2 times a, so 2 times 3. And then we're taking 4 times a times c minus negative 30 all squared all over 4 times a. Okay, so again, we're using the same function, using 3 different methods to solve for the vertex. So negative times a negative is a positive, so this is going to be 30 over 6. 4 times 3 is 12. 12 times 27 is 324, minus negative 30 squared, which is 900, all over 12. Lo and behold, our vertex is equal to 5 and negative 48. So therefore, the minimum is negative 48. And again, keeping in mind, we know it's a minimum because a is equal to positive 3. It's opening upward. And if you need to, draw yourself that visual. It's opening upward. We know that has to be a minimum. Okay, so the a value tells us a lot about our problem, and therefore telling us whether we have a max or a minimum. Okay, let's add some applications here. So when we're looking at max or min, revenue problems come into play. Now, in order to remember how to do max or min revenue problems, we do need to remind ourselves what the demand function is. Well, the demand function P at X, notice it's lowercase p because we do use capital P, so for profit. So demand is P at X is the relation between the price of an item and the number of items sold X. The cost function, C at X, is the total cost of making X items. Revenue, how do we make our money? Is the money brought in by selling X items. Revenue is the product of the demand function and the numbers sold. Now, that function is R at X, so revenue is X times, so the number of items times our profit. Our revenue is the product demand function and the number sold. So R at X is X times P at X. Now, the profit function is the difference between the revenue and the cost. So the profit function is revenue minus the cost. Okay, so looking at example 4, we have the demand function for a new magazine is a lowercase p at x, which is that demand function is equal to negative 6x plus 40, where px represents the selling price in thousands of dollars. And I really want to highlight that because you have to remember whatever we determine, we need to make sure we multiply by 1,000. So a magazine X number sold, and again, 1,000. So that's very, very, very critical. Highlight that. The cost is C at X, which is 4x plus 48. Calculate the maximum profit. So thinking backwards, if we know it's going to be a maximum profit, we know that we have to make sure that our A value is going to be negative in order to have a maximum. So keep that in the back of your head because that's pretty important. If we, determine our function and we don't have a negative A value, in standard form or any of the forms, then we know that we're doing something wrong. For a maximum to occur, the A value has to be negative. Okay, so let's figure out what the first, the revenue function is, because we need that first. So the revenue function is always X times P at X. Okay, so if that's the case, X times negative 6X plus 40. That is equal to, again, distributing negative 6x squared plus 40x. So there's our revenue function. Now, in order to make money, okay, so the profit function, and we want to make maximum profit, we're going to take the revenue function minus the cost function, which makes sense. How much money you generate, however, you have to deduct the cost it takes to make that product. So R at X we know is negative 6x squared plus 40x minus C at X, which is 4x plus 48. Okay, so again, since we're subtracting, silly mistakes happen when we don't distribute that negative product. So I'm going to put arrows just to remind us. So this becomes negative 6x squared minus 40x minus 4x minus 48. So that profit function is negative 6x squared plus, oh, what did I copy this down wrong? So it'd be plus 36x minus 48. Okay, so again, we can approach this any of the 3 methods. We just need to make sure we determine what that vertex is. Now, again, any of the methods works. I'm going to do completing the square. I like to make sure that I have that vertex right away. Again, any of the 3 methods work. Whatever you like to use best, unless it specifies specifically, we can choose any of those 3 methods. So with that in mind, the profit function then is equal to, we factor out that negative 6. We're left with x squared minus 6x. We're going to take the coefficient in front of x. We're going to divide it by 2. We're going to square it. 3 squared, which is equal to 9. So it is equal to negative 6. X squared minus 6x. We're going to add the 9, subtract the 9. We've created that perfect square trinomial. X minus 3 all squared minus 48. Distributing that negative 6. Remember, you only want in front of that binomial because we're creating a vertex form. So expanding, we have -6, x minus 3 all squared, -6 times -9, which is positive 54, minus 48, x minus 3 all squared, 54 minus 48, which would be positive 6. Okay, so keeping in mind the vertex, and it's all in thousands. So the vertex here would be 3 and 6. So that means 3,000 magazines, because we do have to multiply by 1,000. 3,000 magazines results in a maximum profit of $6,000. Okay, so keep that in mind. That's very, very important. You take that vertex, and because it's in terms of thousand, you multiply by 1,000. 3 times 1,000 is 3,000. 6 times 1,000 is 6,000. So answering the question, calculate the maximum profit in the number of magazines sold, that will produce the maximum profit. Therefore, the maximum profit is $6,000, which will be produced when 3,000 magazines are sold. Okay, so again, the thousands, and that's why I highlighted, you do have to multiply those values by 1,000 because that's the units. Okay, last but not least, we have another application would be projectile motion problem. So we have a person threw a ball in the air with an upward velocity of 19.6 meters per second from a 58.8-meter high cliff. The equation for the ball's height, h in meters, at time in seconds is given by h at t is equal to negative 4.9 t squared plus 19.6 t plus 58.8. When does the ball hit the ground? That's where you have to determine what is the maximum height of the ball and what time did the ball reach its maximum height. So again, anytime we know the ball is hitting the ground, we know we have to let the height equal 0. So let's do that. So if we let the height equal to 0, we're going to say for A, h at t has to equal to 0. So therefore, we would have 0 is equal to 4.9 t squared plus 19.6 t plus 58.8. Now, in order to figure out when it hits the ground at that time, we need those zeros. So again, zeros exist, or we can identify easily those zeros in factored form. So we're going to factor our trinomial. Now, in this case, we can factor out that negative 4.9 from each of our terms, and we're left with t squared minus 4t minus 12. So our sum in this case is negative 4. Our product is negative 12. So thinking of two numbers, negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. So then we can say, set up our two brackets, t minus 6, and we have t plus 2. And again, the order does not matter, but you do need to figure out those zeros. Now, because it is in factor form, we can easily identify. You might look at it and say, I know t is 6, t is negative 2. But if you're not sure, take each of those brackets, set it equal to 0, and solve. Now again, although the value of t equals negative 2 does solve our actual quadratic equation, it's something called inadmissible. We can't use it because we can't look at negative time. Okay, so it does satisfy the equation, but it doesn't make sense for our scenario. So we do have to call it inadmissible. So we can cross it out, but we cannot use it. So we can say there, answering the question, therefore the ball will hit the ground 6 seconds after it was thrown. Okay. Now it's asking for the maximum height. So although in the first, in A, we didn't use the negative value for t that 0, we do need to use it in order to figure out what the vertex is. So because we do have the zeros, it's best to take the zeros, figure out the halfway mark. So what does that mean? We're going to take t plus -2, and we're going to divide that by 2, because that means the vertex and the axis of symmetry exist halfway between. So if we take 6 plus -2, we know that is 4. 4 divided by 2 is 2. Okay, so that is that x coordinate of our vertex. And again, we're going to sub it into h at 2. And I'm going to take the factored form and sub in my t value of 2. 2 minus 6, 2 plus 2. So we have -4.9, -4 times 4. So -4.9 times -4 times 4, which is positive 78.4. Okay, so again, looking at our A value, that A value is negative. So we definitely know it's opening downward as we see in the diagram, because when you throw something, what goes up must come down. So answering the question, what is the maximum height of the ball? Therefore, the maximum height of the ball is 78.4 meters. And then C asks us, when does the ball reach its maximum height? And we already know that at t equals 2. So the ball reaches its maximum height of 78.4 meters 2 seconds after it is thrown.